line shutting down for hours because of a single loose bolt or a worn out part. Every minute of downtime costing thousands and thousands of dollars in lost productivity. This is not an exaggeration. ForJob Manufacturing Analytics reports that downtime can cost automotive manufacturing $50,000 per minute. No, that's not per week, per month, per year. $50,000 per minute that the company is losing due to downtime. Today I'm going to explain how preventative maintenance works in manufacturing and why it's critical for efficiency and safety. We'll look at what preventative maintenance is, why it matters, the key methods and tools used to carry it out, and the benefit it brings to you and I, and both workers, employers, and organizations. So let's begin with the basics. What is preventative maintenance and why does it matter? At its core, preventative maintenance is also referred to as a PM. If I say PM, it is preventative maintenance. It's scheduled inspections, repairs, and replacements to prevent unexpected failures. The opposite approach, reactive maintenance, waits for something to break. And that is where we lose the thousands of dollars in downtime, is when we wait for something to break. We wait for something to happen, and we're not preventative. We're not proactive about what's happening. ResearchGate's case studies on successful implementation of preventative maintenance systems 2024 explains reactive maintenance often results in higher cost, production delays, and increased safety risk. I experienced this firsthand in my internship this last summer at Stellantis. I was a maintenance supervisor and I was referred to as a PM coordinator. My big project of the summer was to create a PM kitting area. Basically, this is a centralized spot where you have the parts needed to complete the PMs, so the personnel, your trades, are able to go and grab the parts that they need to complete that preventative maintenance task. You guys will understand what I'm talking about more later. Now that we know what it is, let's explore what it looks like in practice. So how does a PM actually work? It typically follows two main approaches: time-based or cycle-based, and condition-based scheduling. According to L2L's Guide on Preventative Maintenance 2024, time-based scheduling or cycle-based relies on intervals such as every 5,000 machine cycles. If I have a machine that cuts a part, it drills a hole into a part, right? And there's 10,000 machine cycles. If it's cycle-based to 10,000 machine cycles, on that 10,000 hole that is drilled, that is when that preventative maintenance needs to happen. While condition-based PMs uses sensors and monitoring tools to identify early signs of wear. The tools that support these methods are just as important. For example, checklists need to be completed consistently. A TMS, which is a total maintenance system, tracks work orders and histories, and sensors monitor things like vibration, temperature, and oil quality. L2L notes that a TMS provides visibility into maintenance schedules, equipment status, and sources planning, forming the backbone of modern PM systems. As you can see in this flowchart, preventative maintenance follows a simple cycle. If I'm a PM coordinator, I'm going to create the task list. What PMs need to be completed? I will consult with trades and we will figure that out, and then we'll plan the maintenance, and then we'll schedule the work. This is where the time-based, the schedule-based scheduling comes into play. This is where I would say every 10,000 machine cycle, this is where it needs to happen. And then this is where your trades come into play. Your maintenance execution, work completion, and reporting. We can break it down even further. Inspection. Once we figured out that the PM needs to be completed, inspect, detect, repair and replace, and then return the machine to service. That means we fixed it, basically. On this slide, you can see an example of a PM kitting area. For disclosure purposes, I was not allowed to put the picture that I did this summer, the project that I completed, but this is something very similar to what we did. In these bins are parts needed to complete. For example, if I was a pipe fitter and I needed to replace a filter, I would have this filter and then the PM number on there. I could go grab it, grab the paper that I needed, and go complete the preventative maintenance. they could get what they needed right away, and we could prevent big downtimes. Finally, once these methods are applied consistently, the benefits become clear. ForgeAll highlights that manufacturers that adopt preventative maintenance strategies experience up to 30% less unplanned downtime. 30% of the 100 is where we're saving those thousands and thousands of dollars. Beyond cost savings, preventative maintenance expands the lifespan of equipment. Research case studies emphasize that long-term efficiency and reliability are achieved only through systematic machine maintenance practices. So to conclude, preventative maintenance is about being proactive, not reactive. It's the difference between chaos and control in a fast-paced moving environment.